Hello, hello. Let's see what we got here. Says here, why do animals keep evolving into crabs? Tired of these goddamn crabs on this goddamn planet. Okay. Uh, a flat, rounded shell, a tail that folds under the body. Oh, yeah. The crabs do have a little tail thing going on that fold in right by their ass. This is what a crab looks like, and apparently what peak performance might look like. Huh? Peak performance. Bottom feeding? Bottom feeding is peak performance? At least according to evolution. A crab-like body plan has evolved at least 5 separate times among decapod crustaceans, a group that includes crabs, lobsters, and shrimp. You know? And in fact, it's happened so often that there's a name for it. Carcinization. Carcinization. Oh, God. I'm just tempted to say carcinogen every time I see that word. So why do animals keep evolving into crab-like forms? I don't know. Why do STDs evolve into crab-like form? Scientists don't know for sure, but they have lots of ideas. All right. Well, as long as they have ideas, when you can't get answers, you just, you just theorize and then you publish that, I guess. Carcinization is an example of a phenomenon called, well, isn't it already called something? Was it called convergent evolution, which is when different groups independently evolve the same traits. Well, aren't they like in similar environments? So it's the same reason both bats and birds have wings, because they eat insects that fly. But intriguingly, the crab-like body plan has emerged many times among very closely related animals. That's probably why they keep evolving into crabs. The fact that it's happening at such a fine scale means that evolution is flexible and dynamic. Already knew that. Javier Luque, a senior research associate in the Department of Zoology, not ology. Okay, zoology. Is it pronounced zoology even though it's not? Okay. At the University of Cambridge. Crustaceans have repeatedly gone from having a cylindrical body plan, which with a big tail, like the lobsters and shrimp, yeah, to a flatter, rounder, crabbier patty look with a much less prominent tail. The result is that many crustaceans that resemble crabs, like the tasty king crab that's coveted as a seafood delicacy, I didn't know that, aren't even technically true crabs. Oh, shit, they ain't even the real crabs, man. Them fake crabs. And they call the king? Damn. They not true crabs. They ain't down on the block like that. They have adopted a crab-like body plan, but actually belong to a closer related group of crustaceans called false crabs. They didn't even have their own species names. They're just false crabs, because crabs are what it is. Wait, when a trait appears in an animal and sticks around through generations, it's a sign that the trait is advantageous for the species. Yeah. I mean, of course, you got the hard shell. They can close in on themselves to protect their limbs, and they can move pretty fast. And they're bottom feeders, you know what I mean? They can scavenge. They're like homeless, little insect for the sea type creatures. That's the basic principle of natural selection. Animals with crabby forms, some in many sizes, and thrive in a wide array of habitats from mountains to deep sea. Their diversity makes it tricky to pin down a single common trait benefit for their body plan. What do you mean? What's it tricky? A research associate in organismic organismic and evolutionary biology at Harvard University. Did I miss the name? Oh, Jonah Wolf. Joanna? Joanna Wolf. Wolf and colleagues laid out a few possibilities in 2021 paper in the Journal of Bioessay. For example, crabs tuck in their tail versus lobsters, much more prominent one. Yeah, but lobsters can also fold up, you know, keep their tails safe. But also they can't swim very fast when they're doing that. They don't have the hardest shell. Yeah, lobsters are probably easier to catch. And they can't like dig into the dirt like the crabs can. Could reduce the amount of vulnerable flesh that's accessible to predators. And the flat, rounded shell could help a crab scuttle sideways more effectively than a cylindrical lobster body. Yeah, I can see that because lobsters may be faster swimmers, but their natural predators would be fast enough to catch them. As far as a crab, where they can just scuttle into the dirt, dig themselves a hole, and hide there from predators. And anything that can get into their hole is going to get the claw. But more research is needed to test these hypotheses. Wolf said, she's also trying to use genetic data to better understand the relationship among different decapods, crustaceans, to more accurately pinpoint when various crabby lineages evolved and pick apart the factors driving carcinization. All right. I mean, she could, after her research is done, she can finally create more Pokemon for the series. Due to the research, she know the particular evolutionary stages, and she can add to the Pokemon, legend. There's another possible explanation. It's possible that having a crab body isn't necessarily advantageous, and maybe it's a consequence of something else in the organism. It is the body, maybe not, but like just the protection and the shape just adds to whatever the environment advantages is like scuttling and digging and eating off the bottom of the goddamn ocean or whatever. Just a crab body is advantageous, and it can even be amphibious and be on land and stuff. Crabs are cool. The crab body plan might be so successful not because of the shell or tail shape. I didn't think it was the tail had anything to do with it. It's just a way to tuck it into the shell. Um, but like I would assume, what do they use their tail for? Does it guide them when they swim? I don't know. But because of the possibilities that this shape opens up for other parts of the body, said Luque, who is a co-author of 2021 paper with Wolf. For example, a lobster's giant tail could propel the animal through the water and help it crush prey with its tail, but it can also get in the way and constrain other features. Yeah, I mean, it'll get in the way. I mean, they probably can't dig underground as lobsters because like they can't really like enter and exit the hole as fast because they need their tail. They need some freedom in their tail. And if they're trying to get away from a predator, that long body, I mean, they're just a snack. But it can also get in the way and constrain other features. The crab body shape might leave more flexibility for animals to evolve specialized roles for their legs beyond walking, allowing crabs to easily adapt to new habitats. Yeah. Crabs are more adaptable. Yeah, that's also a thing there. Although lobsters do have legs, but I don't know why they have legs. They're like centipedes of the sea. But crabs are like spiders. Some crabs have adapted their legs for digging under sediment or paddling through water. We think that the crab body plan has evolved so many times independently because of the versatility that the animals have. That allows them to go places that no other crustaceans have been able to go. The crab-like body plan also has been lost multiple times over the evolutionary time, a process known as decarcinization. Okay. Crabs are flexible and versatile. They can do lots of things back and forth. Okay. Wolf thinks of crabs and other crustaceans like Lego creations. They have many different components that can be swapped out instead without dramatically changing other features. Yeah. Okay, I can see that. They can when they evolve, they can shed the goddamn the shell on their backs, or they can go full into the shell and become turtles. So it's relatively straightforward for a cylindrical body to flatten out, or vice versa. But for better or worse, humans won't be turning into crabs anytime soon. Of course not. Of course, we're not going to be turning into crabs. We can already survive because of our brains, big old brains. Our body isn't modular like that. Crustaceans already have the right building blocks. They're still dumb, though. They ain't got the brains that don't require that kind of shell action. Anyways, until next time.